right, so welcome back. As I said, our Slack, this conference wouldn't happen without our sponsors. So we want to thank SteamPipe. SteamPipe equals security as code. With SteamPipe's open source CLI, you can really treat SQL to search your cloud resources and build custom security controls. You can leverage their library of 1,000 controls for CIS, NIST, PCI, and more across 40+ cloud providers at steampipe.io. Next up, we have Garrett Wong and Wilson Liu from Google, and they're gonna basically talk about, I think we've been breached. Take it away.
Hello all, and welcome to our talk. I think we've been breached. We're excited to have you here with us today. Here's a quick disclaimer before we continue. This presentation is based on our experiences and on public information only. I'm Garrett Wong, and I have my colleague Wilson presenting with me today. We are both strategic cloud engineers, where we help customers migrate and operate securely in Google Cloud. Our talk today will be focused on the practical applications and implications of the MITRE ATT&CK TTPs directly on Google Cloud Platform, also known as GCP.
Hi everyone, I'm Wilson Liu, and thanks for taking the time to join our talk today. I'm looking forward to sharing our GCP experiences on how to detect and mitigate common TTPs on GCP.
As you may know, the MITRE ATT&CK framework is a public knowledge base of adversary tactics, techniques, and procedures known as TTPs. The framework is used by defenders across industries and in government to find gaps in security tools, aid in threat modeling, as well as implementing security policies. In this presentation, we'll cover various TTPs from the enterprise cloud matrix, focused mainly on GCP. We'll introduce two cloud reference architectures. The first reference architecture is representative of an unsecured GCP project. The second will be of a more secured GCP project. We'll simulate, discuss, and demonstrate the impacts of a leaked credentials event in GCP and look at it from both the red team as well as the blue team perspective. We'll show an example of the leaked credentials. For example, when a service account key is uploaded to a public repository. We'll conclude with security best practices, recommendations around detective and preventative measures to help you improve your cloud security posture. We'll paint a hypothetical story of what can happen in your GCP environment. To set the stage, we have this design diagram right here showing two GCP reference architectures. On the top, there's a project with many default configurations. The bottom shows a project where infrastructure security has been a greater priority. The bottom project has security controls such as VPC service controls to prevent against data exfiltration, OS login to manage SSH access, organization policy to enact organization level controls over projects, and least privilege, a concept that has been implemented on many fronts, ranging from roles to firewall rules and more. I'll hand it over to Wilson next to discuss the incident.
Thanks, Garrett. Imagine you're part of a development team that has strict deadlines and is pressed to continuously develop and release features. At times, the easiest approach to authenticating and working directly with GCP APIs is to generate a service account key file, store it locally, and often in the same directory as your codebase. An accidental commit and you'll unintentionally release your key to a public source code repository. And this is where it all starts. Here's where we bring our presentation to life. We'll discuss actual scenarios and related techniques that allow the attacker to achieve initial access, persistence, exfiltration, and impact on GCP. In the next sections, Garrett will discuss the attacks, and I'll follow with guidance on detection and mitigation of the attacks. I'll also replay the attack against the secured project infrastructure. Passing it back to you, Garrett.
Thanks, Wilson. The first TTP we will look at is initial access, with the technique of valid accounts and sub-technique default accounts. The scenario that we discuss here occurs through a service account key compromise through a public source code repository. Credentials can also be compromised by various other means, such as phishing, key logging, or theft of a laptop. From the attacker's point of view, the attacker discovers the key, accesses and authenticates as the key, and then issues a set of attacks to determine what is accessible. Let's take a look at this example in the next slide. First, the attacker here authenticates as the service account using the gcloud auth activate service account command. The attacker then verifies the name of the service account and then determines what projects the account has access to, for example, MITRE default. Lastly, the attacker here queries the project's IAM policy and determines who has access to which resource. In this next example, we show the attacker using the default compute account to successfully create a service account key. The attacker finds a service account and then generates a key.
Now, speaking from a blue team perspective, there are several ways we can detect and mitigate against this common type of threat. Security Command Center, also known as SCC, provides two types of findings that can help detect for compromised credentials. One, there's a rule to detect if there's any of your service account keys has been uploaded to a public repo, which is more common than you think. Two, there's another rule that can detect if a service account is doing discovery on IAM permissions, which generally should not be the case for robot accounts. You can also use SCC to process your audit logs against known bad IPs and domains. Or you can export your audit logs using Workspace to an external SIM to do additional correlation and detection there. To mitigate against this threat, we have an org policy to disable the automatic editor role grant to the compute default service account to ensure that you're following IAM least privilege. There are also org policies to limit which projects can create service accounts and service account keys, even if you have the right IAM permissions. This will ensure that your developers follow the approved governance process on creating and managing service account keys. And Google recently launched a service called Workload Identity Federation, which allows you to federate with AWS, Azure, or an identity provider that supports OpenID Connect. This helps reduce the need to create service account keys for on-premise or other cloud workloads, and allows you to federate with existing identity providers, which will help you reduce the service account key sprawl problem on GCP. On top of this, we have VPC service controls, which I'll cover more in the other TTPs. Next, I'll show a quick demo of these controls mitigating against this specific TTP. Now, the more secure infrastructure has organizational policies set where the default compute service account does not automatically get granted the editor role, and also the service account key creations are disabled at the organizational level. Here, we are just showing quickly that attacker activates the same default service account key, but does not have any IAM permissions because we have enabled an org policy to prevent the assignment of the editor role to the default compute service account. In addition, if the attacker did have the IAM permissions and tried to create a service account key, the attacker would be blocked by the organizational level policy as shown here in the last error message. Now back to Garrett for the next TTP.
Thanks, Wilson. The second TTP we'll look at is persistence, with an emphasis on account manipulation. The scenario here is that the attacker attempts to set SSH keys as valid SSH keys on a public compute instance. The attacker achieves this through the creation of SSH keys, adding SSH keys to the project or instance metadata, and ultimately can then persist login to that VM. Here we look into the example through the lens of the attacker. On the top, the attacker has already defaulted the project ID and generated temporary SSH keys. The attacker then creates a metadata configuration file for GCP and adds it to the project metadata. The attacker then extracts the IP address of the first VM instance in the project. Next, the attacker is then successfully able to use the SSH command using a SSH private key with no usage of GCP credentials to access the system. The attacker has now added additional credentials and now has persisted access and can authenticate to this VM.
To help detect for the CTP, we have admin activity logs that can be used to detect against instance metadata changes that indicate SSH public keys are being uploaded. You can also correlate the request IP in the audit logs against your known bad IPs to give a higher level of confidence of a compromise. In addition, you can use the cloud logging agent to export OS-level syslogs for analysis or install your third-party EDR endpoint detection tool. To help mitigate against the CTP, we can disable the use of manual SSH keys and manage SSH access through OS logon. OS logon associates the SSH key and Linux account to your Google Cloud Identity account. If the Cloud Identity account is disabled, so is the SSH key access to all the instances. And when using OS logon, SSH access is now controlled through IAM role grants. In addition, we can ensure that these instances are private and not directly accessible to the internet by enabling an organizational policy to prevent public IPs from being assigned to any instances in your organization. This would make it more difficult for the attacker to access the instance from the internet. And if the instance requires access from the internet, you could leverage IAP TCP forwarding, which will allow you to establish an encrypted tunnel to the private instance from allowed IP addresses, identities, and trusted client devices. Now let's see what happens when an attacker tries to use the same TTP against a more secure infrastructure. Okay, so now the attacker manually adds a public SSH key to an instance using the compromised credentials. The attacker gets the name of the instance and attempts to SSH to the compute instance, but is denied access. Now, the attacker knows that they have elevated privileges in the project and attempts to disable OS logon on the project level, but is blocked by the organizational policy to enforce OS logon. Next, passing it back to Garrett for the next CTP.
The third TTP we will look at is exfiltration, focused on transferring data to a cloud account. Accessing an organization's data is a critical objective for many malicious attackers. The attacker wants to conduct discovery of the environment, attempt to transfer data externally, and exfiltrate the data. In this next example, the attacker is authenticated as the key and launches a simple discovery attack to see what data the attacker can access. The attacker issues a copy command to copy the data to an external bucket in an outside organization. The attacker then validates that the data has been successfully transferred. Transferring data to an external bucket within Google Cloud enables usage of the Google backbone, allowing the attacker to exfiltrate data efficiently.
To detect against this type of TTP, you generally need data access logs enabled to detect abnormal reads against your GCS buckets. You can also enable VPC service controls and detect for any data exfiltration log violations. To mitigate against the CTP, VPC service controls help isolate your GCP resources, such as a GCS bucket, to a security perimeter, where you can restrict access to only allowed IPs and trusted clients. So even if the credentials were compromised, resources cannot be accessed outside the security perimeter. In addition, you can ensure that GCP instances can only access a GCS bucket in your perimeter and not able to connect to a bucket outside the perimeter. This will help mitigate against data exfiltration from a compromised instance or insider threat. Here, we'll have VPC service control enabled for a project protecting GCS resources. Here, the attacker attempts the CTP using the compromised service account key. The attacker is unable to list the buckets in the project remotely and is blocked by VPC service controls. Now, if the attacker was inside the network, the attacker can list the sensitive contents in a bucket because the attacker is within the perimeter. Now, if the attacker tries to exfiltrate data to their own bucket, they'll be blocked by VPC service controls. So in summary, VPCSC is preventing the data exfiltration to other cloud accounts, and even with compromised credentials, the resources cannot be accessed outside the perimeter or from the public internet. Passing it back to Garrett on the next TTP.
The last TTP we'll look at is impact with technique resource hijacking. In this example, the attacker's goal is to create and abuse resources within a GCP organization, for example, using VMs to mine cryptocurrency. In this example, the attacker authenticates as the default compute service account once again, and because of their role as editor, the attacker can then create a VM resource directly in the breached environment using the associated command. The attacker is then able to freely create instances across multiple regions with external IP addresses having access to the public internet, which can be used for downloading malware, crypto mining, and more.
All right, to detect for this TTP, SCC has multiple rules to detect against abuse, crypto mining, and outgoing DDoS attacks. You also have admin activity logs that you can export to your external SIM to analyze for suspicious IPs or org policy violations for compute instance creations. To mitigate against this type of TTP, we have several organizational policies to restrict internet access for instances. There are organizational policies to ensure that the compute instances are private and not accessible to the internet by preventing public IP assignments. You can also limit which VPC subnets can use a cloud NAT for outbound internet traffic, and organizational policy to limit which regions compute resources can be created in. Lastly, VPC Service Control supports protecting the Compute API, which is the API used to manage compute resources. Enabling VPC Service Controls adds an additional layer of protection for this API to ensure that the API can only be accessed from allowed IP addresses or trusted client devices. This will help mitigate against attackers using compromised credentials from the public internet. Now, what if the attacker tries to use the same TTP against a more secure infrastructure? Here, the attacker uses the compromised service account key and attempts to create compute resources for Bitcoin mining in US Central Run A. However, the attacker is blocked by the resource location policy, and through a process of elimination, the attacker figures out they can create instances in US West 1A. However, the attacker is blocked by the public IP policy, which makes it difficult for compute resources to connect out to the public mining pools. Now, the attacker figures out that instances can be created without public IPs and attempts to create a cloud NAT so that instances can reach out to the public mining pools. Again, the attacker is blocked on creating the cloud NAT because we have a policy to restrict the usage of cloud NATs within its project. At the end, the attacker might be able to spin up instances, but with a lot of friction along the way and ultimately unable to get internet connectivity to successfully mine some coins. Now, I'll pass it back to Garrett to conclude the presentation.
Thanks, Wilson. So we as GCP security professionals want to be cognizant of the various MITRE attack techniques that can be initiated against our projects. In this presentation, we've discussed potential impacts of a leaked credentials service account key attack, which can have a significantly different set of impacts ranging from no impact to breached compute instances and exfiltrated assets. We've discussed the utility of detective and preventative feature sets within Google Cloud Platform. From a security perspective, we highly recommend that you consider using VPC service controls to protect your production environment, using organizational policies to allow security best practices, prevent misconfigurations, and ensuring that we have appropriate governance processes around service account key creation and SSH access and more. Using Cloud IAM and implementing least privilege. This should always be considered in our architectures, infrastructure deployment, and operationalization of our environments. We should ensure that we have the procedures in place to evaluate our attack surfaces and that the permissions that users and service accounts have are minimal within our organizations and projects. We recommend that you leverage Security Command Center for detection of anomalous events such as coin mining, leaked credentials, or service account self-investigation. Finally, ensuring that you have access to the necessary audit logs, including admin activity, data access, and other relevant logs, helps us to identify where we have issues in our environment. Ensuring that these logs are exported to your third-party SIEM solution for advanced analytics is recommended. The MITRE ATT&CK framework really helps us to think through these scenarios that can manifest in our environment and ultimately improve our current security posture. We encourage you to leverage MITRE ATT&CK to think through common use cases and test them against your GCP environments to ensure that you have the appropriate controls in place. Two additional things that we want to leave you with. We reference the GCP Security Foundation's white paper, which is an excellent starting point for any GCP organization to better secure your environments as well as configurations. And lastly, linked here is an example of the sample attack scripts and logs generated as a result of this presentation, showing the attacker patterns as well as audit log examples. We hope that you have found this content valuable, and thank you all for joining our talk. Additionally, we'd appreciate if you're on a computer or mobile device to navigate over to the link here that's linked under bit.ly and send us over any feedback. Thanks again, and now we're going to transition to a live Q&A.
Thank you. So I think we have 2 questions in Slack and maybe one from the room.
Awesome.
For orgs with a large GCP footprint, how do you recommend handling and disseminating the various alerts and threat notifications?
I'll jump into that, and then Wilson, if you'd like to add to it, feel free to.
Sure.
So for larger GCP organizations, we generally would recommend using a notion called aggregated exports within GCP. Being able to funnel your logs into a centralized project, and ultimately it depends on your organization itself. Many organizations may use a third-party SIEM, but if you're not using a third-party SIEM, BigQuery might be a great option, or looking into Chronicle from GCP to supplement that. But the idea is using aggregated exports to target which logs in our organization are there, and we want to bring them into a centralized source for analytics, auditing, retention, and so on. So putting that at the organization level, we can actually trickle down a log filter event to capture all the logs from all the folders, all the projects, as well as the organization node in our organization. And we're happy to add more to that if there's some specifics there.
Second question, for the various attack types, is there a time where some threat or threat type you would only want to detect, not prevent? So if so, what criteria drives the detection versus the prevention decision?
I'll speak to it first. So between preventative and detective, I think it's a little difficult, and it really depends on kind of the risk posture of any given organization. Obviously, there's some trade-offs. If you prevent everything, you basically can't really have the same level of agility. So we need to find a level of trade-off that works for our organization. In terms of, and I think the reality is we can't really detect every single event. We can't really prevent every single event, so we have to rely on particular detective measures within our organization. Kind of a few things that goes into it is from myself, DevOps trade-off and ability to kind of release resources. Finding an appropriate level of security versus agility, of course, and then making sure that we have the appropriate audit logs enabled. I think to that, the reality is the different audit logs have particular cost associated outside of admin activity logs. So when then things like VPC flow logs or data access logs, they are actually charged with, for example, 50 cents per gigabyte. Many organizations will want to kind of balance that cost by putting stronger preventative controls on an organization. And by doing so, they may not need to generate all the data access logs and can then target their data access logs to be generated only on their most valuable assets and resources. So that's kind of an example of like one trade-off that organizations will look at is really a cost versus agility trade-off. Hopefully that kind of makes sense. But Wilson, if there's anything else that you'd like to add, feel free to.
Yeah, I mean, I'll also add that, there are audit logs that will detect against denials in terms of like if you try to create service account keys or service accounts, there will be an audit log that will be logged if that policy was triggered, right? And there's also, VPC service control audit logs where if there was a block on terms of data exfil, it will be a log generated for that as well. So those are probably another set of logs that can be logged, even though you have the preventive measures in place.
Cool. Any questions from the room?
Last I checked, I think OS login didn't support GKE. Is there a workaround for that if you wanted to kind of maintain enabling that, but also giving exceptions for GKE nodes?
That's a good question. I believe there was a recent update on that. I can follow up with that, but my take on is that they have either improved that or it's supporting GKE now. So I can follow up with that, and either you can reach out to me. I can connect you on the latest updates on that.
Yeah, I remember an update around that as well. So Wilson, if you get the context around that, you can definitely share it.
So yeah, I'm actually looking at it right now. OS login is supported for private GKE clusters, but it's not supported on public GKE clusters. I guess that's the nuance there.
Cool. I think there was a couple comments around, can we post the link to the GitHub and everything else in Slack? So I think folks were interested in that. Otherwise, thank you very much.